Okay, so for this lesson, we're going to be finding the equation of trig graphs, and this one is level 2. So let's go over what we learned from the level 1 that you should have already done. We learned that our sine graph has a y-intercept that is at the midline. So if I look right in the middle of my graph is the midline, so that you're cutting the top and the bottom vertically in half, and that y-intercept is going to go through it. Second thing that you need to know is that the midline in your equation, how high or low the midline is, gets added to the end. So we can do our other midline. For the second cosine function, our y-intercept is at the maximum, and it does not go through the midline for cosine. We also learned about the amplitude, and the amplitude was how high or how low your graph is from the midline. And that goes right out in front of your trig sine or cosine. It was this distance. The only thing that we're going to be adding on to level 2 is if it is reflected, so flipped upside down. So usually your sine starts in a period and has a high peak and then a low peak. We're going to have sine being reflected, flipped upside down, if the low peak comes first and then the high peak. And if that happens with our graph and it's reflected, our A is going to be negative. Usually for a cosine graph, you have your U shape. This shape will be flipped upside down and look more like a hill. And if it's more like a hill, then you'll have the negative sign. So let's do a couple examples. First thing that I'm going to look at is I'm going to find the midline. And when we're looking at the sine graph, we know it's a sine graph because I am starting with that sideways S shape. And so for my midline, we know for sine it goes right through the y-intercept. It had a maximum height up here of 1 and a minimum height of -5. That means the entire length is 6 units tall. So we would just want to go 3 up from the bottom or 3 down from the top to find that midline. We can draw the midline, and we can label it as this midline is y equals -2. And wherever the midline is, goes at the end of your equation. So -2 at the end. Second thing we want to find is the amplitude, and that's how far away the maximum or the minimum is from that midline. So I can go from the midline to the max, and I can see that was 1, 2, 3 units. And I can verify that with the minimum, 1, 2, 3 units as well. So in my equation, 3 is going to go at the beginning. And now we're going to try to see if it was reflected or not. So usually my sine function has a high peak and then a low peak. So looking from the start of the y-intercept, it was a high peak first and then a low peak. So there was no reflection. We're good with just this equation. With 3 as the amplitude, -2 as the midline. For the second one, we're going to look again to find the midline to start. I have a maximum height of 5 and a minimum height of -3. That tells me that I am 8 units long total. So I want to go down 4 to find that halfway point, or up 4. from the max or the min. And I can see that my midline for this example is at y equals positive 1. So at the end of my equation, I need to add 1. Next thing I'm going to look for is that amplitude, and I can count from the midline to the maximum. I went 1, 2, 3, 4. I can verify it with the midline to the minimum. 1, 2, 3, 4. So in front of my sign, I'm going to put 4. And then the last thing that we're going to look for to see is if it's reflected or not. So usually the sine parent function has the high peak and then the low peak. Starting with my y-intercept, I have a low peak and then a high peak. So since I'm starting from the y-intercept, it goes low to high. That tells me that it's reflected upside down, and I'll throw a negative sign in front of that 4. And you have your final equation. You're going to do the same thing, but this page is all cosine. So I'm going to start by finding the midline. I see that the maximum of my cosine is at 3. The minimum's at negative 5. That's a total distance of 8. So I need to go up 4 or down 4 from the max or the min. I'm going to go 1, 2, 3, 4. And we can see that our midline for this example is at y equals negative 1. So I can put that on the end of my equation. I'm going to find the amplitude now, going from the midline to the max. 1, 2, 3, 4, and I can verify it with the other. 1, 2, 3, 4. So 4 is going to go at the very front of my cosine, and now I need to determine if it's reflected or not. And we talked about cosine is usually that U shape from the y-intercept, and if it's upside down, it'll be reflected. So starting at my y-intercept, I do have my usual U shape, so it's not reflected. We're going to leave 4 as positive. And we'll do it again with our last example. We can find the midline. I have a maximum height of 4, a minimum height of 2, so the midline is going to be right in between at 3. That tells me that I'm going to add 3 to the very end. I need to find the amplitude. Going from the midline to the max is 1, midline to the minimum is 1 as well. So I can put 1 here, or I can just leave it off because multiplying by 1 doesn't change anything. And then I'm going to try to see if it's reflected or not. Parent function has this U shape from the y-intercept, so I'm going to go to my graph, and I see that from the y-intercept, it is the hill. It's an upside down U. So it is upside down. It was reflected. I'm going to put a negative sign in front of that 1. And you have your final equation.